Hi, everybody. So today I'm going to talk about some about our products. Kind of hard to avoid in doing this discussion, but what I'd really like to do is talk about what we've done in architecting PON, really so it specifically fits with Volta. I'll explain a bit. Some of this was done specifically with the idea of like an R-core environment in mind. Some of it just happened as part of reducing the size of the product, but it ends up being a pretty nice fit. So just by way of introduction on the company, we are a company headquartered up in Petaluma, California. That's North Bay, not far from here. A group of people, if you go back in the PON world, which I think some of the faces in this room are old PON people, a lot of the founders, myself included, and our head of software development, Paul Gray, who's here, come from Technovus, which was a company that developed the original EPON semiconductors and is now kind of got folded into Broadcom as part of an acquisition. We are designed specifically to be a pluggable device, which fits into what was the original intent when we were doing the design 3 years ago, an NFV and SDN environment. And this is one version. There's a few different physical form factors of it, but we are a pluggable OLT module. It's kind of a confluence of three different disciplines in the company. We are a semiconductor company. We're doing our own ASIC. And so we have an ASIC, a single ASIC, which actually does both 10 gig GPON, which is either XGS PON or NG-PON2. It's the exact same MAC. And also 10 gig EPON. Obviously for the purposes of Chord, we're focused on the XGS side of this, so I won't talk much about the 10 gig EPON. But we work into an SFP plus form factor, and obviously what you have to do in condensing that to get into that form factor, you're dramatically reducing power and incidentally cost a lot in coming down into that form factor. So how do we fit into Chord? I won't obviously go through, it's the whole Chord architecture and objectives, but I will distinguish a bit. So you have different objectives in building a Chord environment, an NFV environment. Certainly virtualizing as many services as possible, and I'll discuss a little bit later about the potential of virtualizing PON as a service or obstacles to doing that. But I focus on the hardware aspects of this, right? So in a Chord environment, you want to create a common switch platform, a common server platform, try and virtualize in software as much as you can, network services, BNFs, but then also have PON work into this environment. And so I've always said, maybe I'm a bit jaded as a guy who's worked in the telecom environment for 25 years, but if you're innovating into technology and you're only affecting operating efficiency, right, by making software easier to manage for network operations, it's not enough to drive purchasing. You really have to impact things, either driving new revenue or impacting the CapEx side of things. I don't know if the carriers in the room would agree, but these are the real drivers, right? And so no matter what we talk about in Chord, it really has to have a hardware impact that has a meaningful, its bottom line impact for carriers. So I kind of start with, what did PON look like? Still today, these are, OLTs that are deployed, but a legacy OLT. You have a modular component in that you have pluggable optics into an OLT, and the rest all fits in a chassis, right? So you have, what could be line cards with a dedicated MAC, and typically, it's what you've got in a line card. You have a fixed capacity. There's no way to adjust that by an individual PON port. You have a MAC that's providing service to 1, 2, 4. I think 8 would probably be the maximum number of PON ports or OLT ports from a single MAC. Probably an onboard CPU and the memory you need to drive that. Perhaps at a line card level, but certainly at a chassis level, you're doing switch aggregation depending on the vendors. And then in the legacy OLT world, you have software control directly on that chassis itself. If you look at, there's a lot of different configurations. But if you look at what that means in an individual line card, you have these discrete components. So what I was talking about, a MAC, which may be supporting 2 OLT PON devices, maybe more, like I said, 4 or 8. You have dedicated uplink. You have control on that board itself and the memory associated. You may or may not have traffic management. Maybe you're doing this in an aggregation switch in a chassis. Maybe you're doing it at the line card level. And then a lot of the other components you need to actually make that line card function. So if we go to the next step, and I did not mean for that to, there we go. There. That wasn't intended. Anyways, so you have your movable optics there. But at the line card level, you still have a lot of these components which are fixed in a configuration. So you have a fixed MAC, which is managing 1 or multiple PON ports, which is a fixed configuration on the device. You still have management CPU. You may or may not, again, have aggregation on that. You may do switch aggregation for a number of ports, 16 ports, 48 ports on a line card itself. But you are able to take the aggregation switching into, what would be a cord-like architecture, an NFV data center architecture, and use a standard top-of-rack switch. And you're able to optionally then pull the software control, it's away from the system itself. You may be doing some onboard management, but it gives you the option of having remote software management, OpenFlow based or otherwise. And so what we've done is really trying to take this to the extreme of how much can you reduce the actual hardware components in a network to really fit into a cord environment as much as possible, is to take everything out of that PON-specific device possible, so that you're pulling out switching, you're pulling out CPU management, you're pulling out local management that you don't need, and fitting directly into what is a common and cord-defined switch, right? So this becomes, it could be the same switch that you're using top of rack, could be a switch you're using at individual line card levels, and then you're aggregating all of these at a top of rack or maybe an end of row, right? It even allows some further configuration where you're reducing the amount of switching. But we've basically taken everything out of this device that you don't need to be OLT specific. I say if you're trying to design an automobile and figure out all the things you don't actually need to make that work, try designing it to be the size of a skateboard, right? And as you find out pretty quick, what are the things that you don't need? But we are in that device itself. We have a single 10 gig MAC for 10 gig PON, XGS PON, or NG PON 2. It is fit in the optic module, right? So the actual device got here is actually the size of it's a little bit longer than a standard optical transceiver. And we put the MAC inside it. It is by far the lowest power OLT implementation. We do have an embedded CPU. You still need to be able to interpret management commands, but these come to us in band. So everything for managing this device comes via the switch, comes to us layer 2 in band. And so that CPU is really minimal functionality. You're not doing any of the things. You're not managing switching capabilities. The switch itself has those management capabilities. You're doing things like unpacking OMCI to send that through to an ONU. And all of that lets us then sit on a common platform layer 2 switch host. It not only gives you the ability to then put management further up in the network, right? Could be local at the switch, could be at the rack. This could be 100 miles away at it's a network operating center. But it actually means this is the only way to manage this. This really forces remote management into the application, and again fits really well then in a cord architecture. If you look at it from another perspective, I won't spend much time on this slide, but what we're really doing is removing an entire layer of the network, right? So that you're fitting into a common switch host platform. As an aside, I don't know why this was animating. As an aside, this is actually what has happened in the cable world, and that was one of the drivers. I said at the beginning that our design was partly specifically for central office cord-like environments, but part of the design of Tidbit was actually to meet this remote node requirement, where if you're putting something, and the cable carriers are looking at putting remote nodes as far as 100 kilometers away from a head end, they wanted those to be low cost, low power, and the least amount of functionality you need to put in a remote node. And so it's a very similar concept. What's the minimum amount of functionality you can put in a PON network that's sitting out in a sealed container, and then pull all of your management back into the head end.
Sorry, is this Tidbit hardened so it can't go in a hot environment? Or?
As long as you can pull the heat away from this, right? And so yeah. So we will fit. That's a whole kind of part that we don't talk about when it's mostly central office focused discussions. But yeah, we have a hard
remote, and it's going to be in a cabinet somewhere.
With no airflow. Yeah. There is an extended temp version of this. Yep. So just to kind of carry through what I was talking about. So if we're trying to minimize what you need in hardware to provide PON in a cord environment, it begs the question: well, why not take an additional step? Why not make an OLT a virtual network function, right? Put it into software. And we have been asked that, actually. And what it comes down to, and I think many people who have worked on this are aware of this, there is functionality that you need to run at the line rate. So you have to do traffic scheduling, you're going to have to do FEC, you're going to have to do things like encryption that have to run at line rate. And so you're either doing that in a Mac, or you're taking a CPU and putting a lot of accelerators around it, which make it probably at the end more expensive and less efficient anyways, just on a cost performance. So it's the reason why, I think, Cord has been showing this since the beginning. You talk about a lot of other functionalities, NAT and firewall, as common server-based functionality, but PON is always put out on its own. So in some form factor or another, at least the way the technology exists now, the PON really needs to be running in some kind of dedicated form factor, right? So either an ASIC like Tidbit does inside the module. There's companies that do FPGAs, but either way, it's a dedicated device. There are some impacts it has on actual performance. This gets a bit deep in the weeds on the hardware, which is not really necessarily the scope of today. But by actually your jitter budget for an SFP is actually pretty high compared to PON performance. So putting the Mac, literally millimeters away from the actual optical module ends up giving you a little bit better gain, which you can either use for higher capacity or longer distance in a PON. So there's some benefits too of actually having a Mac, not just in our configuration, but others that are able to put this close to an optical module. So that was a lot about hardware. Like I said, I think this is important, even though I'm talking about some really specific things we do in the design. I think the things that we put together in Cord really do need to meet some of those metrics of reducing CapEx and making this a more efficient solution from a cost perspective, from an implementation perspective in the network. But the result is, right, so like I talked about, you now have this device that is hosted on a common switch, plugged into an SFP plus port on a 10 gig switch, which must be remote managed, right? You don't have any other options this way. In the Cord environment, we're looking at OpenFlow, ultimately provisioned via Volta, and I'll talk about that in a minute. You also have the cable world, which is looking at doing this via DPoE, and it's a similar construct. It's something that we've worked on, and some people within our company, like Paul, have worked on in a previous life, but still similar concept. But you don't have a choice now with this module. It has to be remote managed. So it's all in-band. There's no additional hardware management. You have to work in a layer 2 switch environment. There's no unnecessary switching capability, so we're not duplicating anything the switch does. Only handling PON functionality. And like I said a few times, removes everything that's not mission critical to actually making PON work. So now to kind of wrap this up into Volta, so we're sitting here kind of architecturally, like I've described in the network, hosted in a layer 2 switch in a cord environment. You're then directly tied into that switch environment. So if you're doing kind of service provisioning across this, it's kind of a natural fit in that we're an element of the switch. We're a port. In fact, some of the requirements we get inside and outside of Volta is as much as possible to make this PON port just look like an extension of an Ethernet port. So you're effectively going from an NNI to multiple UNIs and running flows through that, which is kind of the design of Volta. But the fact that we're actually hosted directly on a switch, right, in a common element switch, you're doing port provisioning across the whole network that way. So I didn't plan to talk in a lot of detail otherwise about some, there's a lot of things that we'd like to discuss within Volta. We have been, as Sean is aware, kind of absent a little bit as we've actually been getting our product out and ready for commercial deployment. But I did want to bring up a couple things, because I know there's going to be some discussions on Volta later of some things architecturally and conceptually that we see making Volta easier to deploy. So I've got these up as general comments, but I'll talk in a little bit more detail. One of the things we're starting to see is a lot of carriers, especially out of Europe recently, asking us about how do we get started. So we like this idea of Volta. We haven't spent much time on it. We've been kind of following it peripherally. How can we go in and download Volta and actually start testing on it, right, with Tidbit solutions or with other solutions? And I think right now it's still a pretty difficult process. This has been discussed already. Better documentation would obviously help, and so everyone's aware of that. But I think tying closer releases to adapter releases, especially, obviously where companies are making their adapters publicly available, would make things a little bit easier. So a company knows if they're downloading the Volta 1.1, this is the adapter release that goes with that. And I think those things are not tied in necessarily directly. And then, of course, everything that we've discussed before about making this easier to download and implement. But we're starting to see a lot of interest in this. We are starting to see carriers that actually want to go download Volta and start experimenting with it. And there's very few carriers that have the depth of experience that AT&T has with this, and maybe a handful of other companies. And I think that needs to be made easier, both from a Volta core environment and from vendors like Tidbit that are providing an adapter. We are we had some discussions about this earlier today. In the interest of making this interoperable, which is one of the principal objectives for carriers actually deploying cord, we still want to try and maintain that line between the Volta core and the Volta adapters as strictly as possible in making them hardware agnostic. One of the things, to take a high-level example, but it's a really good litmus test for this, when Volta started out, it was actually intended to support the cable world and EPON as well as XGS PON, and that's broken now. I'm not necessarily sure that's absolutely the objective, and it's I think Volta is going to move forward with XGS PON and other PON variants. But if you look at things that get implemented in the Volta core that speak to GPON specific implementations and XGEN ports versus LLIDs in the EPON world, it's a good indicator that there's not enough abstraction going on in the Volta core. There's several other things we've talked about. In terms of functionality, some of the things that may get done in the Volta core, which are very hardware specific. I think one of the things that came up, which was a point of contention, was the allocation of specific GEM port LOC IDs in the core versus letting the hardware do this. So there's elements like this. And so I think now that Volta is getting into a more regular cadence, we're getting closer to actually having a commercial deployment. That's something we're interested to see carry forward in terms of a stricter regimen on the core versus the adapters. Same thing is true with the PON performance. One of the things, a lot of people within Tidbit had spent time working on, what was the EPON version of interoperability. And one of the things we saw most successful in getting multiple vendors to cooperate around a common standard was to make sure that the core element, the virtualization element, was not dictating performance for the actual hardware. Because then you have vendors kind of fighting each other up in the core as opposed to allowing them to do more implementation at a vendor-specific adapter level. So anyways, I mean, these are comments, I think that take a lot more time to discuss out, but I think it was as we are now, Tidbit, getting more involved in Voltha as our product is coming out. These are some things we're starting to notice from an architectural perspective. And so with that, I welcome any questions. I'm walking out, so I leave all the questions for Paul here, who's our software architect. But we'd be more than happy to discuss more on this.
Okay, so let's thank the speaker.